Okay, our final page here, we have g defined as 2x to the fourth minus 8/3 of x cubed minus 1. On what intervals is g decreasing? Okay, so this is a first derivative test. Right, we're interested when g prime is negative. So let's get g prime. The derivative of 2x to the fourth will be 8x cubed, and the derivative of 8/3 x cubed will be 8x squared. The derivative of 1 is 0. So there's g prime. We want to set that equal to 0. We can factor out an 8x squared, and when we do so, we have x left over here and 1 left over there. Right. 8x squared is equal to 0 when x is 0. X minus 1 is equal to 0 when x is 1. So we need a number line with a 0 and a 1. All right, we're going to have to pick some test values, maybe -1, 1/2, and 2. We're going to plug them into the original first derivative. Right? Not the original first derivative, the factored first derivative, I think is the best way to go. -1. -1 squared is a positive, so we have a positive. -1 minus 1 is a negative. So that's positive times a negative, which is a negative. 1/2. 1/2 squared is positive, times 8 is positive. 1/2 minus 1 is negative. So we end up with a positive times a negative again. That is also negative. And then finally 2. 2 squared is 4, times 8 is positive. 2 minus 1 is positive. Positive times a positive is a positive. We're interested when g prime is negative. So we're going to say on the interval from -infinity, way over here, all the way to 1. Right? During this time, right, this g will be decreasing. So it's right on this interval, g is decreasing because g prime is negative. How about when is g concave up? Okay, well this is now a concavity test, which means we need g double prime of x. The derivative of 8x cubed is 24x squared, and the derivative of 8x squared is 16x. We're going to set that equal to 0. Two terms, they have an 8x in common. If we pull that out, we have 3x, and then 16x divided by 8x is 2, so that's equal to 0. If x is 0, this is 0, and then we have 3x minus 2 equal to 0, so add 2 to both sides, divide by 3. 2/3 is our other possible point of inflection. So we're going to throw those two numbers on the number line. Right. Pick some test values, -1, 1/2, 1. Plug them into the second derivative. If we plug -1 in here, we get a negative. If we plug -1 in here, -3 minus 2 is a negative. Negative times a negative is a positive. How about 1/2? 8 times 1/2 is positive. 3 times 1/2 is 1.5. 1.5 minus 2 is a negative. Positive times a negative is a negative. And finally 1. 8 times 1 is positive. 3 times 1 is 3. Minus 2 is 1, which is positive. Positive times a positive is a positive. We want concave up. Concave up is going to happen when g double prime is positive, and that was on the interval from -infinity to 0, and then again from 2/3 all the way to infinity. So we got to give both intervals. We also have to give that reason. Remember, the reason is very important, right? Because g double prime is greater than 0.